Now the piece that we made out of aluminum earlier, this is a fender made out of exactly the same material. This is 063 3003 H14 aluminum, and about 45 minutes worth of work, and we've got a really nice one-piece aluminum fender. The thing with shrinking is much like Ron Covell tells in his latest videos. If you think of metal like a piece of pizza dough, if you want to shrink the edges, it's going to get thicker. We all know that. Metal does the same thing. As this piece was shrunk, this should get thicker. Well, I mic'd out the middle, and it was 063 right down the middle like it was supposed to, but on the edges here it actually measured 070, or about 10% thicker on the edges. And that's really the theory of shrinking. So now let's... This is a fender we looked at earlier. It's for a 21-inch front tire for a long chopper. It was done entirely with the shrinking dies like we showed earlier. And when you do things with a shrinking die, or anything by hand for that matter, the key is to get it uniform from side to side. And when you look close, this isn't bad, but it's not as uniform as I would like from side to side. That's where these dies are in the Noka Power Hammer right now. These are Delrin dies, which were cut out of a piece of Delrin plastic and put in these simple tool holders. And this is where you really need that large gap for the dies. The design of the hammer allows for that large gap. This die here has the exact shape of the fender that I want to have. And when you look at it, here was done with the shrinking dies. But all of a sudden there's a transition where it's nice and uniform from side to side. I actually pushed this fender through these dies up until this point, and you can see that where that transition is. So these dies essentially just tighten up the shape, I can call it, which basically means it's more uniform and more symmetrical side to side. In this close-up view, you can see how the fender would be placed in here, and as the hammer works, would actually be tightening up the shape or transferring the shape from these inexpensive dies into the part. This view also brings up another unique feature of the Noka Power Hammer, and that is that these dies are 90-degree tool holders, can be rotated 90 degrees. If these dies were held in just one position, you would quickly hit the hammer. But because we can go 90 degrees, we can get it extremely tight up to the dies and get quite a curvature there without hitting the machine.